Hello guys, today we are going to see about recursion. So before going to a practical note, so let's understand the what is recursion and where we apply the recursion. So basically recursion is the technique of making a function call itself. Okay, and this techniques provides the way to break complicated problems down into a simple problems which easier to solve. That means if you know about the algorithms, like binary search will be there, so that whenever like that binary search uses the divide and conquer technique, and that technique follows the recursiveness. Okay, so whenever we split the list into two parts and we are going to search that element recursively. Okay, what happen if we use this recursively? So this will skip the iterations. Okay, suppose we split that list into a small chunk and search that element recursively. In that case, I got that element in first chunk or first part of the list, then other iteration will get skipped, and by skipping those iterations, internally or by default performance will get increased. Okay, so to solve this kind of problems, recursion will be there. Okay, so let's understand this concept practically. I'll be going to show you a simple program which follows the recursion. So I'll create one simple function for you guys. So let's create it. I'll write some public static void. So as of now I'm not going to return anything, okay, as a part of this function. So like I'm going to give the name for that function, like mm, perform recursion. Okay, and to track the count of that recursion, so I'm going to add some number here, and then by using that number we can track that count, recursion count. Then we can see the how many times the recursion happens. Okay, so I'll add one console statement here. uh, by, by seeing that statement we can conclude. Okay, so I'll give the statement like a recursion count. Okay, so so here let me add the n. Okay, so I pass the 10 or I pass any number, so this statement will get printed, and after execution of this statement I'll give the recursive call. Okay, so here I'm going to pass the n minus 1. What happen when I pass the n minus 1? Suppose I pass 10, then it prints first, prints the recursion count 10, then it call again statement by passing the n minus 1, that means 9, then again it prints the recursion count, then again this statement call this function recursively. Okay, so let's understand the sequence of the execution first. Okay, let's call this function from the main method, and let's observe the execution. Okay, I'm going to execute this program, let it build and execute. Yeah, now we got the expected output. Okay, many people like saying like why we are getting the exception here, because whenever we are going to add the recursion functionality for particular function or method, so we have to think about the you like we must have to think about the endpoint. So we provide any endpoint for this function, we just added the recursive call, and to track this recursive call we added this function like statement. Okay, then how we can track the how we can end that recursiveness. Okay, so for that we have to give the some conditions here, like I want to execute this recursion till the 0. When n reaches to 0, then I can stop the recursion. Okay, then I can stop the recursion. Then in that case we can simply return. Then what happened, we only got this statement on a console. Let me execute again and show you how it works. See, then again there is one more question. So this should be like, so first time this execution, this 1 is printed, 2 is printed, 3 is printed. Why? I passed 10, then first time the 10 should be printed, the 9 should be printed, 8 should be printed, 7 should be printed here. But why it happens? Because JVM internally maintains the stack. Okay, stack of the method calls. And as we know, stack follows the last in first out execution. Whatever call registered last, so that get first chance, so that call get first chance. That means this is the this this is the 10 is registered in a stack at the first. Okay, 10 is registered in the stack at the first, and 1 is registered in the stack as a first at the last. And stack follows the what? Stack follows the last in first out. So this order stack follows. So that's why, so this one get executed first time, then second get executed second iteration, third get executed in third iteration, and 10 get executed at the end iteration. That means, so this is the first element and this is the last element. So last element get first priority and first element get last priority. So that is the concept of the stack. So I think you guys need to check that one. So that's why we got this output like this. So that is the concept about the recursion, how recursion work. Now we are going to see some like one of the more function, like that functions, like many interviewers ask that question, like how to find the factorial by using the recursion. So we are we can able to find the factorials by using the traditional way, like we are going to use the loops, and or we can iterate that loops from n minus 1 to something 1 till the 1 or something. Okay, but sometimes interviewers ask that questions to like get the factorial or calculate the factorial by using the recursion. Okay, so let's write the code to write the to calculate the factorial by using the recursion. Okay, so I'm going to write one function to calculate it. Okay, so like I'll give the static. Okay, now in that case we need to return the some value to the caller function, that means factorial. Okay, so or I'll give the calc factorial. This is method, and for which number we have to find the factorial, so that number we have to pass here. Suppose I want to find the factorial for 5, I want to find a factorial for 10. In that case we can pass it as a part of this number. Okay, so now let's add the end condition, that means termination point for that recursion. So as I give here now, so this is whenever n reaches to 0, then stop the recursion. So same thing I have to give here, like whenever n is equal to 0. Okay, this is the end condition, and I sorry n is equal to 1, then return the same number. So this is the condition. Okay, n returns whenever n reaches to 0 or 1, then return the same number, whatever number we have. Okay, but if it is not 0 or 1, then find the or then do the recursive call for that calc fact method. Okay, directly return this method here and just do n into calc fact and just pass the n minus 1. Okay, so what happened when we pass the n minus 1? So in the first iteration, so I pass the, let's example I pass the 5 here. Okay, and it will check this condition, so both are false. Okay, then it is not, that condition is not satisfied here. Then after that, in the here, okay, add this statement, n is a 5, 5 into n minus 1, that is 4. Okay, then again 4 into n minus 1, that is 3. So that kind of calls will get registered into the stack, and that stack will get, when that stack will execute this calls, then this calc method will get return, this calc method will return the exact output or exact factorial for given number. Okay, let me call this method and show you the output. So this is the 5, I want to find the factorial for the 5, and let me print that factorial calc fact. Okay, let's observe now. See, so we got a perfect answer. Okay, so for the 5, so this is 120 output. Let's try for the 6. Let me see whether it is working fine or not. Okay, so yeah, that's too good. Okay, so that's all about recursion, guys. Let me know if you have anything, any doubt or any questions regarding this recursion. And yeah, thank you guys, thank you for watching this video. Thank you.